Welcome to our video. My name is Changjun,
My name is Allan Nunez.
My name is Yusuke Tsutsumi.
and we are mechanical engineering students at Georgia Tech taking a course in design manufacturing, and we're here to discuss about our top 10 special topics that we have learned and discussed in this class.
So for the selected topic, here we have ergonomics and human factors. Simply put, ergonomics is the incorporation or the study of how a person can work in his or her environment, whether it's using a tool or a product or even software GUI, or even a procedure. Human factors is what goes into play through a human's mind, where it impacts how they perceive and how they would incorporate a product or procedure in their life. Now, applying this, a designer would look into what makes their product best integrate with the user, best helps them work together. Some industries that need ergonomics desperately would be the automotive industry and some hand tool designers, for example. Automotive industry has to consider their car seats, for example, something comfortable to be able to sit in. And hand tools, they need to be able to be comfortable. Take a hammer specific that needs to be heated repeatedly over and over again. That handle's really bad, your hand's going to be hurting after a few hits. And UIs need to be simple and navigatable. They aren't, then a person won't be able to use it properly. The importance of this is we want to be able to bridge the living between the non-living, essentially, where that can be seamless, then integration would be quite simple. Now, designing and manufacturing can make better products simply by considering human factors and ergonomics, because their product will last longer, because it's easy to understand, and it won't be that hard to interrupt their lives with. Capabilities is we can further understand the human psyche, and some limitations is that obviously to get this data it takes time, and every user isn't quite the same. Second topic we have is very important. We have the lean management principles, which essentially is something that we want to incorporate into whether it's a factory or a procedure. We want to eliminate waste entirely, but also keep the customer at the center. And everything that we do to a process or to a procedure, we want to keep the customer in mind while also keeping our resources low, essentially. The importance of this is we want something that's customer-centered, that our value comes from our customers, since that's who's going to be purchasing from us. So waste management is one of the most important factors. We'll look into reducing what is muda, some waste. Using in design and manufacturing better products, we obviously want to approach this Kaizen philosophy, which is something that tells us to constantly keep moving forward and keep improving, while always be developing our processes and our systems to be up to date always. Now, capabilities is obviously we want to improve our efficiency and reduce our costs, but some limitations that one may worry about is their job security. Is my job going to be eliminated in the next iteration of procedures? Next, we have value stream mapping, which also is included in this this package of lean management. Specifically, value stream mapping it tracks our value. It's a diagram, it's a model that a company can use to see points of weakness or points of waste that can be eliminated in the next iteration of our management. So manufacturing can use this. It streamlines their processes, it streamlines their assembly machines, and we can easily identify waste or easily identify spots of weakness. The importance of a value stream mapping is that we can find limitations, like I said, but also understand our system and easily explain it to newcomers. And anyone that can analyze our system can perhaps immediately notice that, hey, maybe there's a limitation in production in this specific area. Uses in design and manufacturing, application of value stream mapping to organizations can transform their operations to deliver more value to the customer. Again, reducing that waste, reducing spots that aren't needed anymore. Hence efficiency, fostering culture. We can have a better unity inside our workplace. But always, the customer is kept in the center of our processes. The customer's value is always kept as the important factor, and ultimately the end goal that we have to keep in mind. Capabilities, we can see clearly our system and some limitations that it takes some time to incorporate and constant work, since it needs to be continuously modified. And finally here I have one of my favorites that, if you recognize who I am, this is the Kana model. Kana model just simply takes into account customer satisfaction, customer requirements to how well a product executes. Importance is that a company can look specifically into how well it's meeting customer satisfaction, and it gives a company a good spectrum of what they need to accomplish versus what wow factors they need to include, if any. Design and manufacturing products, this model tracks what customers want, which is great for engineers, as we learned from 2110, that the customer has to be the center of where we start, really. It's capable. We can get feedbacks from what we need, and it limits our. We need time to collect this data, and it takes a large amounts of data since every person is quite different.
Next topic is Cobot. It is a small or medium-sized robot that works with people in a shared workspace. It is used for industries that require repetitive tasks such as automotive, packaging, and construction. Some importances of Cobot is that it is consistent and it increases productivity. It is easy to assemble and program with useful apps and software, and it can easily learn new operations and is able to work on different production processes. Some uses to design and manufacture better products. It divides workloads so that while cobots are working on repetitive tasks, workers are able to work on tasks that require creativity. Cobots perform tasks with high precision and accuracy, which improves product quality and reduces errors. And also, cobots can be easily programmed for new production processes, which allows them to quickly adapt to design changes. Some capabilities of cobot is its safety, which reduces the chance of injury for workers when working with robots, its mobility and versatility. Some limitations of cobot is that it requires human supervision for regular maintenance and adjustments to be made. It's limited speed, so it is not recommended for high-speed production, and it has power constraints for safety, so it is not suitable for handling heavy objects. The next topic is generative design. It is a 3D CAD capability that uses AI to create optimal designs from system design requirements. It is used in industries such as architecture, manufacturing, and industrial design to design complex, high-performance products or improve structural stability. Some importances is that it improves efficiency by automating manual and repetitive tasks involved in the design process. It reduces design time, allowing time to explore design alternatives quickly. Its flexibility and adaptability to various design constraints. Some uses to design and manufacture better products. It generates design ideas that could include unexpected solutions that could satisfy user needs, and it can balance multiple objectives simultaneously. Some capabilities is that it is cost-effective since it speeds up the design process and reduces manual iterations. It increases creativity since it allows designers to explore a wide variety of design options, and it improves sustainability. Some limitations is that it depends on initial input, where unclear goals or inaccuracies in the data can lead to unusable designs. It also has high cost and compatibility issues where integrating the software into the existing workflow and systems can be difficult. Next topic is minimum viable product. It is a product with enough features to attract early adopter customers and validate the product idea. It is used in industries such as e-commerce, healthcare, social media to create simple products and add features as they receive user feedback. Some importance is that it is able to gather the most feedback with the least effort. It is cost effective by reducing the risk of wasting resources to make a product that does not meet user needs. It is used to design and manufacture better products by testing an idea with fewer users before committing a large budget to the product's full development. And also the feedbacks received will be used to make design changes to the product to better meet user needs. Capabilities is its faster time to market, which gains competitive advantage. It's building a loyal customer base, and its user-centric development, which ensures the product meets user needs and expectations. Some limitations are its compatibility, which focusing on core features may make it difficult for the product to be compatible with other devices. Its scalability, which may become a concern if the product demand increases. And lastly, the limit of scope, which leaving out features that are critical to certain user groups.
Now to the special topic, digital twins. It is a virtual representation of a real-world object, system, or process, and it uses real-time data to mirror the physical counterpart, allowing for simulation, analysis, and monitoring. For its applications, it is used in various industries to optimize performance, predict maintenance needs, and improve efficiency. In manufacturing, it is used to optimize production process, product quality, and predict equipment maintenance needs. In the energy sector, it helps in monitoring and optimizing the performance of renewable energy sources. And in healthcare, it can help create personalized treatment plans by simulating patient-specific conditions and responses to treatments. For its importance, digital twins are important in enhancing decision-making, providing a real-time virtual representation of physical assets, enabling a more informed and faster decision-making process. In cost savings, it helps by optimizing processes and reducing failures, and it helps in personalization, such as in healthcare. It can help create personalized treatment plans and improve patient outcomes. Digital twins are used to design and manufacture better products by being involved in prototyping and simulation, allowing engineers to create virtual prototypes and run simulations to test different designs which help identify potential issues and optimize designs before the physical production begins. It saves time and reduces cost. In predictive maintenance, it can predict equipment failures and maintenance needs, ensuring machines operate efficiently and reduces downtime. In quality control, it can help to monitor the production process in real time and identify defects or deviations from the desired standards. As previously stated, its capabilities include optimization, real-time monitoring, simulation and modeling, and remote management. For its limitations, however, it has an high initial cost, as implementing digital twins can be expensive due to the need for sensors, data storages, and processing capabilities. There's the concern with data privacy and security, because the use of real-time data in IoT devices can result in cyber attacks and unauthorized access. It is also dependent on accurate modeling. It is only as good as the model it is based on, and inaccurate or outdated models can lead to incorrect insights and decisions. Moving on to retrofitting. So retrofitting involves updating existing buildings, systems, or equipment with new technology or features to improve their performance, efficiency, and safety. Applications of retrofitting include it's commonly applied to buildings for energy efficiency by upgrading the HVAC systems, industrial machinery for improved productivity, and infrastructure for safety and resilience. It is important in cost savings, as it is more cost-effective to retrofit existing structures and systems than to build new ones from scratch. In sustainability, it extends the life of buildings and equipment, reducing waste and minimizing the need for new resources. And in adaptation to modern needs, as it allows older structures and systems to meet contemporary needs and technologies, keeping them relevant and functional. It is used in design manufacturing, better products by integrating advanced technologies, allowing existing machinery and production lines to incorporate the latest technologies such as automation and AI to enhance the capabilities of older equipments and making the manufacturing process more efficient and precise. Enhancing quality, updating systems and machines can produce higher quality products with greater consistency, reducing the likelihood of defects. Assisting with flexibility and customization, allowing the manufacturers to quickly adapt to changes in product designs or market demands, offering more customized products without extensive retooling. Its capabilities include energy efficiency, reducing overall energy consumption and costs, extended lifespan, extending the useful life of buildings, machinery, and infrastructure, delaying the need for costly replacements, enhanced safety. Retrofitting comes with modern safety features and standards, and reduces risk and enhances the protection of personnel and assets. For its limitations, it has high initial costs. It is upfront investment, especially for larger, more complex systems. Compatibility issues, ensuring new components and technologies are compatible with existing systems, can be challenging and may require additional modifications or customizations. Space constraints, physical space limitation in existing buildings or infrastructure can restrict the extent of retrofitting that can be achieved. Lastly, lights out manufacturing. So lights out manufacturing is a fully automated production process that requires minimal or no human intervention. The entire production process is managed by advanced technologies such as robotics and machine learning, and by reducing the need for human workers, it lowers the risk of workplace accidents and injuries. Its applications include the automotive industry, such as Tesla and BMW, that utilize highly automated production lines to assemble vehicles, including tasks like welding, painting, and the assembly of complex components. In consumer goods, the use of lights out manufacturing is used to produce everyday items like household appliances, toys, and packaged foods. In aerospace, employing automation to manufacturing components for aircraft and spacecraft. Its importance include that it offers increased productivity. Automated systems can operate continuously without a need for breaks. Reduces labor costs, allowing companies to invest more in technology and innovation. Enhanced quality control. Automation ensures consistency and precision in the manufacturing process, and scalability, allowing companies to easily scale the production up or down on demand without the need for extensive retooling or additional labor. It is used to design and manufacture better products by having precision and consistency. Automated systems ensure that every product is made with the same level of accuracy, reducing the variability that can occur with human involvement. Rapid prototyping and iteration. Companies can quickly produce and test prototypes, allowing for faster iteration and improvement of designs, which then accelerates the development process and brings the product into the market more quickly. And cost efficiency, automation reduces labor costs and minimizes waste, allowing more resources to be allocated to research and development, leading to more innovative product designs and enhancements. As previously mentioned, its capabilities include automation, precision, scalability, and cost efficiency. And finally, for its limitations, it has a high initial investment. Setup costs for a fully automated system involves substantial investment in machinery, technology, and infrastructure. It has flexibility issues. It can be less flexible when it comes to quickly switching to new products or processes. It may have initial downtimes as systems need to be set up and employees need to be trained. Here are the references that we have used when researching and brainstorming these selected design and manufacturing topics. And before I end this video, I would like to stress that we completed this project based on the knowledge learned from the design and manufacturing course. And this was just purely for educational purposes, and we were not aware of any potential current or past videos that have also covered these topics. Thank you for listening.